Today we're going to validate parentheses recursively without using a stack. Now most methods that you'll see will oftentimes tell you to parse the string from left to right and push an open parentheses onto the stack and pop anytime you have a closing one, and at the end of that, if the stack is empty, then you have balanced parentheses. To do this recursively without a stack, we're going to work with the intuition that you can recursively delete the innermost pair of parentheses, and if after doing that there's nothing left, then you had a balanced parentheses grouping all along. If, however, you delete the innermost pair over and over and you still have something left, then it was not balanced to begin with. So I'm going to do this in Wolfram, but I promise it's conceptually portable to whatever language environment that you use. The only two base cases that we have are checking if there's nothing left, if so return true, and checking if you can delete anything. For example, with this, I can't delete anything, but it's also not empty, so it must be false. So let's get started. Here I have a method called validate parentheses, which takes in a string. This which block here is just essentially for control flow. Just think of it as a series of if statements. And I'm going to give it a default operation, and that default operation is just to call itself. So I'm going to do something called string delete on our string s, and the thing I'm going to delete is this, is the innermost parentheses that it will be able to find. Like in this string, it would be this is the only occurrence of that. And I'm going to pass that back into my method. This is where the recursion comes in. So that's the operation, the recursive operation. Let's add our base cases. The first one is checking that string length of s is 0. If that happens, then it's true. Either it's completely empty to begin with, or we have successfully deleted all the innermost parentheses, leaving us with nothing. The second base case we're going to look at is whether or not deleting does anything. If I run string delete on this, it doesn't do anything. Yet we know that we still have something in the string because we passed through this case. So this would be string delete of s, looking for those parentheses, is just equal to plain old s. And if that is the case, if we try to delete and we can't, and the string is not empty, then we must have unbalanced parentheses. And this is the default case, hence the true. So let's define that. Let's try it out. Let's give it a simple case of balanced parentheses. We get true. Let's unbalance it. Get false. Let's give it nothing. That's true, that kind of makes sense. So there's nothing there, it can't be unbalanced. And finally, let's give it another weird one. So you can see it's validating here. And that's how you can validate parentheses recursively without using a stack.